Hello, pharmacy professionals. Welcome to the first of a four-part series on allegations, perhaps the most confusing uh, calculation that pharmacy technicians and even student pharmacists have to learn. Uh, an allegation is one where you are mixing two different concentrations to make a third, and you have to calculate how much of each. So if you are mixing a 30% cream and you have a 40% cream and a 5% cream, how much 5% cream do you have to use to dilute the 40% cream to make a 30% cream? Oftentimes, you'll be given a quantity of either the 5%, the 40%, or the 30%, and you have to find the other quantities, or you will simply be asked to figure out how many parts of the 5% you have to use, or how many parts of the 40% you have to use in order to mix the 30%. And in the second video, I will be discussing what that is meant by parts and why did I draw my calculations like this. Well, that's the tic-tac-toe method. We'll be going over that in part 3. And what if you have a 1%, a 5%, a 40%, a 50%, a 70%, and you have to use all of them to make the 30%. What do you do then? That'll be part 4. But what do I mean when I say percent? Well, that's what this video is about. In this video, we'll be discussing concentrations. So what is a concentration? A concentration is a way of describing an amount of a substance in a given volume, or a weight of a substance in a total amount of the total substance that it's in. For instance, if I were to say that I have 1 gram of miconazole in a 30-gram tube, then what I am saying is that I have 1 gram per 30 grams of miconazole. Pretty simple. But how would you express that in a more easily understood way? And if you had a tube of miconazole cream on the shelf, it wouldn't say 1 gram per 30 grams. It would more than likely say a certain percentage, and it would probably be a percentage weight per weight. And what does that mean? That's kind of an unintuitive way to express concentration, so it bears some explaining. The units that you will most likely see concentration expressed in pharmacy is percent weight per weight, percent weight per volume, or percent volume per volume. Usually it's one of these two, though. So what is meant by percent weight per weight or weight per volume? So percent weight per weight is a way of expressing grams of a substance of interest in 100 grams total. For example, you might see 0.3% weight per weight. And what that means is 0.3 grams of the drug in 100 total grams within that tube. So in the tube, you will have Of the 100 total grams of cream, 0.3 grams of that will be the drug. What's another way of looking at that? So let's say you have, let's say this green stuff right here is the base. So just like cream base, inactive cream. And this red part right here is the active drug. This active drug will be weighed and it'll be 0.3 grams. But this is a 100-gram tube, so we need to add 99.7 grams of the base. And as you can see on this scale, that adds up to 100 grams because 0.3 grams active drug, 99.7 grams of base, 100 grams total cream. And on the box of the cream, you will see that it says 0.3%, which means 0.3 grams per 100 grams total per cent per 100 grams. Now, that is also the way that you would express the volume per volume, the percent volume per volume. You would have 20 mLs of substance of interest in 100 mils total solution. So those 100 mils will be made up of 20 mils of substance of interest and 80 mils of some other substance, some other diluent. So you would have 20 mils substance of interest, 80 mils diluent, which equals 100 mLs total. And that's the ratio. If you were to have 500 mLs total, then you would calculate how much, in order to calculate how much of the active drug you have, you would take 20 mLs per 100 mLs. That's what's meant by 20%, 20 mLs of active ingredient, 100 mLs total. So 20 mLs over 100 mLs is our ratio, equals how many mLs in 500 mLs. So that's our, we are equating these two ratios. 200 mLs of active ingredient is in 100 mLs total solution. So how many mLs are in 500 mLs of total solution? And if you remember your math, you would cross multiply 100 mLs times X equals 20 mLs times 500. There's that cross multiplication. So X equals 20 times 500. That is 10,000 divided by 100 equals 100 mLs. Which means that in a 20% solution, if you have 500 mLs of a 20% solution of drug, you have 100 mLs of active ingredient. That is what is meant by 20%. 20 mLs per 100 mLs. And that's 20 mLs volume per volume. So let's look at some examples. So we have here also weight per volume. If you have a percent weight per volume, what is being described is 1 gram per 100 mLs of solution, which means that of a volume of 100 mLs, you will find 1 gram of active ingredient. So a 10% volume per volume solution would contain 10 grams of drug in 100 mLs of solution. So if you have a 5% solution of, let's say, ibuprofen, and that is a 5% solution of ibuprofen, and let's say that we have 50 mLs of it. How much ibuprofen in grams is in that bottle of 5% ibuprofen? So 5% means 5 grams of ibuprofen in 100 mLs of solution. You can probably already tell that a 50 ml bottle of ibuprofen would have 2.5 grams of ibuprofen in 50 ml solution. And you can see that we did the same thing that we did before. We created a ratio from the percentage. 5% means 5 grams of ibuprofen per 100 ml of solution, and we equated it to X grams ibuprofen over the given volume. 2.5 grams of ibuprofen per 500 mLs of solution. So let's look at some examples. We have a mad scientist, and he mixes 3 grams of chemical X in 1 pint of sterile water for injection. What is the concentration of chemical X in terms of percent weight per volume? And just for your reference, 1 pint is 473 mLs. So what is the concentration? We have 3 grams of chemical X, and we have 473 mLs of total solution. Now, assuming that chemical X isn't going to be adding anything to the volume, which you can't always assume, but in this case, let's just assume that, we are asking what is the percent in weight per volume. So how would we set up this problem? Well, just like before, where we have a percent meaning the number of grams of substance so just like before, where we have percent meaning number of grams of substance per 100 mLs of total solution, we can set up our problem in the same way. 3 grams of chemical X over 473 mLs equals how many grams in 100 mLs? Can you see how the answer, when we find X, will be the percentage of our solution? Because what we are finding is the number of grams per 100 mLs. So just like before, we would cross multiply. So 3 grams times 100 mLs equals 473 mLs times X grams. .300 grams equals 473 times X. So 300 divided by 473 equals X. So let's pull out our calculator and do that equation. Let's pull out our calculator and do that equation. 300 divided by 473 is 0.63%. And because we set up our problem to give us grams per 100 mLs, that is our answer. So the mad scientist has a 0.63% solution of chemical X. Let's look at another example. The mad scientist receives a chemical burn while mixing chemical X. He must mix a burn cream which contains 0.5% weight per weight lidocaine in a cream base. How much lidocaine must be added to make a 30-gram tube? So how would we set up this problem? We have a tube of burn cream that we want to make. Burn cream. And it weighs 30 grams. Let's assume that that's the cream inside of the tube weighs 30 grams. And of those 30 grams, 0.5% is made up of lidocaine. So 0.5 grams per 100 grams is lidocaine, and we have a 30-gram tube. So 100 grams would contain 0.5 grams, so 30 grams would contain how many grams? How much lidocaine must be added to make this 30-gram tube? So let's cross multiply. 0.5 times 30 equals 100 times X. So that's 15 divided by 100 equals X. So we would need to add 0.15 grams of lidocaine. What would that look like? Well, let's bring our scale back down. Let's bring our scale back down. So we want our scale to read 30 grams. So how are we going to do that? Let's assume that this is the cream base and this is the lidocaine. The total amount is going to be 30 grams. So what would we add to this scale? So the total is 30 grams. Of that, some portion is going to be lidocaine, and some portion is going to be cream base. It's important, I drag this out because it's important to realize that the lidocaine is going to contribute some weight to the total, and the cream base is going to make up the rest. So we know that we will have 0.15 grams of lidocaine, and we know that we will have 30 grams total, which means that we would subtract 30, we would subtract 0.15 from 30, and what would we get? 29.75 grams of cream base, 0.15 grams of lidocaine, and that will give us 30 grams total. That's how we would mix this burn cream. Number 3. The mad scientist tries his chemical X to experiment again. This time he adds 100 mLs of ethyl alcohol to the pint of chemical X into the solution of example 1. What is the final concentration of ethanol and chemical X? The ethanol would be in volume per volume. The chemical X would be in weight per volume. Well, we will remember that the solution in example 1 was 473 mLs total and had 3 grams of chemical X. And to that, we are now adding 100 mLs of ethyl alcohol. So our question is asking, what is the final concentration of ethyl alcohol in this solution, and what is the final concentration of chemical X? Well, what's contributing to the final product? So we're going to add 100 mLs of ethyl alcohol, which means that we will have 473 mLs of solution to which we're adding 100 mLs of ethyl alcohol to give us a total solution of 573 mLs of total solution, of which 100 mLs is being contributed to by the ethyl alcohol. So, how would we find the percentage? Remember that the percentage is the number of milliliters, because this is volume per volume, per 100 milliliters total. And we know that we have 100 mLs of ethyl alcohol, and we have 573 mLs total. That's our ratio, 100 mLs of ethyl alcohol for 573 mLs total. We want to know how many milliliters of ethyl alcohol there is in 100 mLs, because that's our definition of a percent. At least a percent volume per volume. So let's cross multiply. 573 mLs times X equals 100 mLs times 100 mLs, which gives us 1000 mLs right? No, that gives us 10,000 mLs. 573 x, divide both sides by 573. Let's get out our calculator. $10,000 divided by 573